Hello everyone, good afternoon. Some people are still facing issue to join. I don't know why. Did you face any problem in joining? Usha?
Yes, sir.
No, I'm saying, did you face any problem in joining? Because I see some people are sharing difficulty in password,
No,
some
no,
identity.
sir.
Oh,
No,
right.
sir. It is okay. Yes, sir.
There are so many people messaging still for password is not working, but it's all same password working, right? Which I said, correct? Maybe. Jayasuri, are you there? Because I can see Jayasuri joined, but again, so many meeting notice joining. So, hi Vasu, did you face problem or all good?
No, sir. In previous class, I faced a little bit of issue, but now
So,
it's okay.
okay, so guys, what happens generally, your browser cache, there it sometimes stores and all. That's why it happens. So you reset your browser cache, guys. That is the best thing I've found out. Otherwise, it should work because password I don't change unless there's some problem. So good. We'll wait for 1 or 2 minutes. We'll start. So yesterday we started discussing the basics of integrals calculus. We call it primitive. We call it antiderivative, and we talked about basics. So today we are going to solve little more deep, little slowly we'll increase the level in next few classes, and finally you will see that we have reached very deep. Integral calculus, as we know, it's more a reverse operation of differential or derivatives. So let's start. Let people join, and in between let people join. Okay. So okay, so we have Adit Suryansh, we have Hi Suryansh, we have Brahmappa. Brahmappa, finally you are able to join. Welcome. Then we have
Thank
Jayasuriya,
you,
we
sir.
have Tusham, we have Usha, we have Vasu, and still a lot of people are missing. You will not believe, guys, because I think it's because I have said, okay, I'll give videos. So let's people are joining because there are 22 people who have registered for this course overall. You will not believe. So let's start. So, okay. Yesterday we started discussing about integral calculus. We said if we know basic function x to power n, we can integrate. If we know trigonometric function sin x, cos x, we can integrate because we know differential. We also learned about reverse of log x. Also, there is one more. We also talked about exponential e to power x remains same. There is one thing we didn't talk about. Let's do that also, and then remember when we done differentiation of a to power x. What was the differential a to power x between when we did?
AX log A.
Correct. It was a to the power x same and log a and base e. Base I am not writing it. So that is the differential of x. If I take log a to the left side, let me put like this. If I put a to the power x by log of a, so then in differential will be ax by log a into log a, so a to the power x. Correct? Because log a is a constant. So if I modify the differentiation a to the power x divided by log a would be a to the power x, right, everybody? So that is why if I integrate a to the power x, what you will get with dx obviously? You will get back a to the power x by log a. We discussed exponential and trigonometric function, but a to the power x will work like this. Sorry, not log x, log a. Right? So integration of a to the power x would be a to the power x by log a and plus c always. I explained yesterday why plus c is important. So today what we are going to do is we are going to talk many of the integral of x to the power n form, a to the power x form, sin x, cos x, trigonometric form, log x form, or some of this form. Right. So a is a constant. You are right. A is any constant, and here log a means base is e exponent. Right, Suryansh? So let's start solving few questions. if I give you, I'm going to do a lot of mix and match, and I'm going to explain you how to do it. Suppose if I give you very simple question, integrate with respect to x 3 to the power x plus 2 dx. How will you integrate? And here we know 3-4 things. We know integration of x to power n, we know integration of a to power x, we know integration of 1 by x, we know integration of trigonometric function, we know integration of e to power x. We know this. So how will integrate 3 to power x plus 2 with respect to obviously dx? Any ideas? See, integration is more about putting our all creativity, because it is not that simple. No, today is only level 2 we are doing. But when you do reach level 4, 5, 6, you will feel that yeah, it's really challenging and very interesting. 3 to power x plus 2. We don't know anything to power something plus something plus something minus. So what we'll do is, you will split. You will say 3 to power x. You know how power works. This can be said 3 to power x multiplied with 3 power 2 or not. Right, everybody? 3 to power x plus 2 can be write as 3 to power x into 3 power 2 or not? If you know how exponents work, powers, right? And then dx. So in fact, my question becomes now 3 to power 2 is 9, which is constant. 9 is outside. Integration 3 to power x dx, which is a very standard form of a to power x. Now you can integrate very easy. So how will you integrate now this?
Three x square upon 2.
So what will happen? No, it is not x to power n, guys. You are thinking x to power n. It is a to the power x. Just now I explained what is a to the power x.
Sorry.
9 will be constant. A to power x integration is what? We just talked about. It is a to the power x by log a. So it will be 3 to the power x by log of a, and here my a is what? A is my 3. Yeah, base is okay. Plus c. That is my answer. Everybody agree? It is 9 into 3 to the power x by log 3 base. That's it, plus c. Any confusion, Usha? Anyone? Suryansh? Easy? Next question. Suppose if I say integrate sign, you can always say this, but I'll write with the integrate. Suppose if I say 2 and dx, and if I say 1 minus or 1 plus cos of 2x. How will you do it, guys? Integrate 2 by 1 plus cos 2x dx. How will you do it? And I said integrate requires a little bit of thoughts. No, we don't know, right? Because we don't know integration directly of cos 2x in the denominator. So we have to apply some trigonometry here. As we know, cos 2x is what? What is cos 2x? It is 2 cos square x minus 1, right, guys? So everybody has done class 10 trigonometry. It is 2 cos square x minus 1. Everybody agree? Now, why this will be helpful? Let's see. Cos 2x is given by 2 cos square x minus 1. So if I take 1 here, 1 plus cos 2x is nothing but 2 cos square x. And we already know integration of, 1 minus 2 sin square x also is there, Suryansh. You are right. We can use any of that. But I am using this because I'll tell you the reason. So if I do that, 2 as it is, 1 plus cos 2x becomes 2 cos square x. Now, what is the reciprocal of cos? Secant. 2 and 2 got. Dx is there anyway. So, finally, my question becomes secant square x dx. That's it. And which everybody knows. See, the art of integration is you have to bring into the form which you already know differential. We know differential of 10x is secant square x. So, integration of this would be 10x plus c. That's it. 10x plus c. Right, everyone? Very easy. Any question, anyone? Very easy. Let's move on. Suppose I say, if I give a question something like, say, little bigger question and try to solve that and tell me again the method, more than the method. Suryansh, we can apply that formula also. But then you get cos x square, right? So we can apply that also because finally trigonometric functions can be represented into one another. Because we already know secant square x will become 10x. That is more easy, right? That's why we are done with this. It's all, try to make it simple, which are more easier formula available. Suppose if I say integration of x cube and say 5x squared x cube plus 5x squared plus 4x plus 1 divided by x squared dx. Dx anyway, even if I don't say, you can assume dx is a 4. How will you solve this? It's more about how will you solve it, not about getting the answer exactly, but how will you approach this? Jai Surya, Suryansh, Brahmappa. Brahmappa, how should I pronounce your name?
Baramappa, sir.
Baramappa, okay.
Yes.
So x cube plus 5x squared plus 4x plus 1 by x squared dx. How will we integrate? Suryan says split. Split into various function where you say x cube by x squared plus 5x squared by x squared plus 4x by x squared plus 1 by x squared. So this function become x cube by x squared. What we are doing is we are splitting. This is separate, this is separate, this is separate, this is separate. So if we write that, what become x cube by x square? X only, plus 5x square by x square, 5 only, plus 4x by x square, 4 by x, and finally 1 by x squared. That is what my quotient becomes. And it becomes very easy now. Right. Again, it's not about standard form, Jai Surya. It's about to make it into the form which we can solve. Yes, you can say, but I don't want to use that a plus b plus c. It's like we know how to integrate x, we know how to integrate 5, we know how to integrate 4 by x, we know how to integrate 1 by x square. So what is integration of x? X to power n form. So x square by 2, correct? What is integration of 5? Constant is there. So 5x, because I am doing with respect to x. What is integration of 4 by x? 4 is constant. Integration of 1 by x is log of x. Log of x. In fact, you can say x is this. How will you do the last one? Integration of 1 by x squared.
X to the power minus 2.
We will make it x to the power minus 2. When you make x to the power minus 2, my answer would be
Minus 2 plus 1 by
minus 2 plus 1. So minus 1 by minus 1. Or it become minus 1 by x plus c. Correct? That's it. So easy. People are joining now, little late, guys. So It becomes x square by 2 plus 5x plus 4 log x plus, minus 1 over x plus 3. That's it. Any confusion? Very. Objective here is, let's learn little bit of techniques. Then so when we go more deep, you can do very easily. Let's try another one. If I give you this kind of question, how will you do? Integration of, and suppose I say, okay, let me put the root also now. And then I say 1 plus sine of 2x dx. Again, I want the ideas. We can solve it. 1 plus sine of 2x dx. How will you solve? Ideas. Again, it's no trigonometry come into picture. So sine 2x, everybody knows.
We can write 1 as sine square x plus cos square x.
Right. Point is sine 2x we know. Sine 2x is 2 sine x cos x. But it will not help alone. Because even we put 1 plus sine, let's put that. Okay. So suppose my question becomes now 1 plus sin 2x is 2 sin x cos x. पर इससे कोई फायदा नहीं है because अभी भी मेरा रूट के अंदर ही जो है and तो 1 plus 2 sin x cos x. Now we have to think जो जयसूर्या ने बोला है. We have to somehow what is the okay again guys the point is the thoughts. Objective is somehow we try to remove the root. If you are able to remove there are some fingertips you can say points. One is always try to remove the root, always try to remove the denominator, always try to make it the form of differential which we already know. We should always do that. So this time what we'll do is sin 2x is 2 sin x cos x, no problem. But still there is a problem. So this one will write as sin square x plus cos square x because we know the identity sin square x plus cos square x equal to 1. So this time we are going to use the reverse of it. We are going to make 1 as sin square x plus cos square x. And why we are doing it? Can you tell me, Brahmappa, why are we doing this?
To remove root, sir.
So how it removed will move because now it becomes sin square x.
Yes, sir.
It becomes sin square x plus cos square x plus 2. So this is a simple algebraic identity of a plus b whole square, right?
Yes, sir.
That is why. So guys, we have used here simple basic algebra also. Everybody know a square plus b square plus 2ab is equal to a plus b whole square. So when you take out of the root, it remains only sin x plus cos x. So now we got rid of the root. We know integration of sin x. We know integration of cos x. We are good here. Ideally, we should write plus minus also. But since anyway, when you're going to integrate, we'll get sin and cos. We are good. So while your answer would be sin x का क्या होता है minus cos x and cos x का होता है plus sin x. My answer is simple. This is my answer. After you able to substitute, उसके बाद तो बहुत easy है. Main thing was this and this. So integration में what it is, you have to start thinking how do I make it simple, how I can get rid of denominator, how I get rid of roots, how do I get rid of something which I don't know differential. So we'll make it to do that form which we know it. Okay. Now one question is for you. Let's see how many of you can do this. Okay. Shall I move on? Usha, all good?
Yes, sir.
Good. Virendra, Vasu, all good? Mahesh? So let's solve this question, which says integration of, I'm not putting integration sign, just I put in the question. Cos of x minus cos of 2x divide by 1 minus cos x. And don't tell me answer first. Let's think and let's discuss the ways. How can we solve this question? Tell me what we can do to solve this.
One minus cos 2x formula you can use, sir.
So you are saying we'll replace this?
No, sir, denominator.
1 minus cos x you multiply with 1 plus cos x.
No, sir, some cos 2x formula can use, sir.
Cos 2x formula तो यहाँ पे लगेगा, वही पूछ रहा हूँ मैं. Think about it, guys. What all we can do? See, lot of algebra and trigonometry will be used. Think about, guys, and tell me. Okay. So someone is saying we'll substitute cos 2x. Yes, we can do that. So instead of cos 2x, what can I put it? 2 cos square x minus 1. And again, I said last time, if it is cos, let it be cos. Don't try to book it sign unnecessary unless they sign by cos or cos by sin something. So instead of cos 2x, what are you going to put it? 2 cos square x minus 1. Let me put a bracket. So guys, I am overwriting it. Instead of cos 2x, I am putting 2 cos square x minus 1. Let me put a square also here and show you. And then tell me what else still you do. This is what it is. Correct? Now what? इससे तो कुछ फायदा हुआ नहीं आ रहा. We can rationalize the denominator by multiplying with 1 plus cos x. We can do that, Tusha. We can do that also, yes. But with that, what will happen? 1 minus cos x into 1 plus cos x, 1 minus cos square x, sin square x. Good. We can do. But what happens? You still remain sin square x in the denominator. Numerator still is very heavy. Now I'll tell you what we can think of. What we can think of. If you start thinking little more, first open the bracket. Okay? You will be again amazed. Open the bracket. So this is gone. And this become plus 1. Agree? Everybody? Cos x minus 2 cos square x plus 1. Right? Now what? Now if I, okay, remove this bracket. I want this to make it positive. So I'll do everywhere with minus. So I am multiplying minus 1 in the top and bottom, and I'll tell you why. So I am multiplying minus 1 on the top and minus 1 in the bottom. So let me write again so that everybody understands what is happening. In the bottom, when I multiply with minus 1, it becomes cos x minus 1. In the numerator, it becomes minus cos x plus 2 cos square x minus 1. So I'll arrange in the form of highest to small power. So let me write, it becomes 2 cos square x minus cos x minus 1. Agree? Two cos square x minus cos x minus 1. Now, if you really see, अगर आपको, if you don't get this कैसे होगा, तो एक मन में सोच लो कि एक quadratic equation है, just मन में सोचने के लिए, because it's a quadratic equation, you can solve and get the factors out of it. How? I'll put this in the right side just to explain that. See, 2 cos square x मतलब क्या होता है? 2 cos x into cos x. Or you can also say cos x, let me write it, 2 cos x into cos x minus. What I'm trying to tell you is we'll factorize using the quadratic thing. So I'll give you a very easy way. एज्यूम कि से cos x इक्वल टू से y, जस्ट टू इमेजिन, तो क्या बन जाएगा तुम्हारा 2y स्क्वायर minus y. I'm not asking you to substitute, I'm just asking you to imagine 2y square minus y minus 1, right? minus 2, उसका फैक्टर क्या बनेगा 2y square. Everybody know how to split the middle term, right? 2y square 2 into minus 2 का बनेगा 1 and minus 2, so minus 2y plus y. I split at the middle term, तो ये हो गया. Let's see the common, 2y is common, क्या बच गया y minus 1, फिर plus 1. I am only using the quadratic today, so finally when you do it become 2y plus 1 and y minus 1. We are able to factor this. इसका मतलब कि we can write this 2 cos square x minus cos x minus 1 into form of 2y plus 1 or y minus 1. This is just a example. So let's do it now. So we'll write this in the form of this 2y plus 1. तो लिख लेना मुझे यहाँ पे 2y plus 1. y हमारा क्या था cos x. So 2 cos x plus 1. एक तो ये फैक्टर हो गया. दूसरा फैक्टर क्या था y minus 1, मतलब कि cos x minus 1. ये मैंने यहाँ पे s लिखना भूल गया. This is the numerator. Denominator is, we already know cos x minus 1. Bracket लगा देता हूँ so you can look similar. Correct? This all. Did you understood everybody what I did? Now it become very easy. Just to show you that this equation जो यहाँ पे दिया था ना, you can factor it out. That is the only thing we did. We factored it. This is gone. Quotient becomes only this. Integration of 2 cos x plus 1. ये मैंने double click किया. 1 second. That is what? How you make it simple. Right, everybody? Not very easy. 2 cos x plus 1. Solve. Everybody know. Plus 2 sin x plus x plus c. Main point was getting rid of denominator. This. Tell me anybody any question. Integration of this everybody knows, right? 2 sin x plus c. Everybody understood how we got this? We used this to factor. Just to explain you, I used cos x equal to y. Otherwise, we can do directly also here. Tell me on chat. Yes, no, doubt, whatever. We are going to use a lot of trigonometry. That is sure. GTG, sir, got it, good. Okay. Now I'll give you another non-trigonometry thing. See, it's all about how algebra you use. It's all about algebra. Let's try another question. Integrate, if I say x to power 4, let me write y so that doesn't look multiply, okay? Y to power 4 plus y squared plus 1 over. The problem happens when we have denominator also something very bad. In this case, y square minus y plus 1 dy. Again, I want ideas, guys. See, integration we are going to do just in the form of ideas how we'll solve. Integration of y4 plus y square plus 1 divided by y square minus y plus 1. What are you going to do?
सर ऊपर
And
वाला
yeah,
y square plus 1 can it be y plus 1 y minus 1 और नीचे y को
y
y
plus 1 y
into
minus
y
1 तो y square minus 1 हो जाएगा ना.
sorry
But yes, you are thinking on the right line. Who is speaking? Vasu?
हाँ जी
Vasu, you are speaking on the right line. Think more of that. It's a factorized thing only. How? Brahmapa, speak. What factorize? You are right. How? Y to power 4. देखो guys, what we should do is think, okay, कि हमको अब देखो I am changing the question, rearranging. ये y2 square minus 1 y square minus y plus 1 है. मैं माइनस y को इधर लिख देता हूँ फॉर ए मोमेंट. इसको हटा देता हूँ. इसको ऐसे सोचो, शायद कुछ फायदा हो. हम कुछ करने वाले हैं थोड़ी देर बाद. y स्क्वायर प्लस 1 माइनस y. इसको भी मैं y स्क्वायर फॉर्म में ले आऊं कैसे भी ना, y स्क्वायर प्लस 1 और समथिंग समथिंग, तो काम हो सकता है. Pause it, just to think. That is the only thing we can do, right? We can think of how we can make in the form of this. अच्छा, y स्क्वायर प्लस 1 का स्क्वायर क्या होता है करके देखते हैं. चलो ठीक है. जस्ट थिंक इन द माइंड, y स्क्वायर प्लस 1 का होल स्क्वायर करोगे तो क्या होगा. अगर उसका स्क्वायर करके देखते हैं कुछ होता है तो it will help us something. Let's think. It will become y4 a square plus b square plus 2ab. थोड़ा कुछ तो आ रहा है, एक एक्स्ट्रा आ रहा है, लेकिन आ तो रहा है कुछ, राइट? Are you getting what I'm just giving you a hint. y स्क्वायर प्लस होल स्क्वायर क्या होगा? y टू पावर 4 वो न्यूमरेटर में है, प्लस 1 न्यूमरेटर में है, प्लस 2y स्क्वायर, एक एक्स्ट्रा y स्क्वायर आ रहा है. ठीक है, देखा जाएगा. एटलीस्ट इतना तो हो रहा है, राइट? एग्री एवरीबॉडी? So what will I do is, see now because of this fact, I'll here add plus y square and minus y square. ये dy हटा देता हूँ. We know it's there. Okay, guys, what I did, I added plus y square and minus y square in the top intentionally. क्यों? अब क्या होगा? ये y square plus y square I can write as 2y square. So ये चला गया. Just to write step by explaining this, correct? So my question is still, अब देखो, मुझे चाहिए था y4 plus 1 plus 2y square, वो है already, right? This one. So I can write this in the form of y square plus 1 whole square. This whole, इतना. Let me put a this point, this thing, I can write as like this, right? So if I substitute this, मेरा डिनोमिनेटर में क्या हो गया? सॉरी, okay. So this is what. So now my question becomes y square, and guys, any step you feel difficulty in, please stop me. Y square plus 1 whole square माइनस y स्क्वायर, ये तो है टॉप में, और नीचे है y स्क्वायर प्लस 1. मैं ब्रैकेट हटाता हूं कि नो यू कैन विजुअलाइज. नाउ टेल मी व्हाट विल डू. आई सिंप्लीफाइड द क्वेश्चन टू वेरी एक्सटेंट वेयर आई हैव सम कॉमनिटी बिटवीन न्यूमरेटर एंड डिनोमिनेटर. नाउ टेल मी गाइस. ब्रह्मप्पा, जय सूर्या. यस,
a plus b into a minus b.
एग्जैक्टली. जैसे इसको देखेंगे हम, it will look a square minus b square मतलब a plus b into a minus b. Correct guys? ये मेरा है a, तो a square. ये मेरा है b, तो b square. a square minus b square is a plus b into a minus b. तो लिख लेते हैं हम a plus b into a minus b. तो a plus b into a minus b. a क्या है मेरा? y square plus 1. So y square, तो a प्लस b, तो प्लस b, और a माइनस b, फिर से y स्क्वायर plus 1 minus y. ये हो गया ना? मैंने टॉप को लिख दिया है a plus b to a minus b, डिनोमिनेटर तो सेम ही है. अब तो सबको दिख रहा हो, एवरीबॉडी कैन विजुलाइज कि क्या होने वाला. नो, इट्स वेरी इजी. Now what? Obviously this is same. My question becomes only this, which everybody knows how to integrate y square plus 1 plus y, correct? What you learn from this example? What is the main trick we use in this example, Usha?
Sir.
बताओ क्या इससे क्या आइडिया आया कि we should try to make numerator or denominator into one form where we can replace something, right? Algebra use करी हमने. हम लोगों ने देखा y square plus y minus y था नीचे, ऊपर y to power 4 था, तो we just think it worked. It worked. Right, Usha? It's all about algebra. That's it. Anybody, anything, any question? Is anybody in doubt on this or clear in this?
Clear, sir.
Chalo, move on. If I give a simple question of, let's move to trigonometry a little more again. If I tell you, let's solve, first of all, a simple question. Integrate, again, integrate with respect to x only. If I say 2 plus 3 cos of x by sin squared x, dx तो already है, सोच लो. तो क्या कर, what we can think of? Tell me guys, what we can think of? What of integration we already know in trigonometry? We know for secant square, we know for cos x square, correct? Those are useful. I told you we have to form something in the form of which we know. We already know, right? Integration of, we already know differentiation of tan x is secant square x, cot x is minus cos x square x, sec x is sec x tan x, cos x is minus cos x cot x. ये चार काफी है. इंटीग्रेशन रिवर्स ऑफ दैट. तो क्या करने वाले हैं बताओ? जय सूर्या, सूर्यांश. 2 plus 3 cos x divided by sin square x. First of all, we'll split. ये बन जाएगा 2 by sin square x. Right, everybody? 2 by sin square x plus 3 cos x by sin square x. एकदम easy question है ये. And this one is only level 2 today. We are going to do next week level 3, 4. अब क्या होने वाला है? What is 2 by sin square x? Everybody knows 2 cos x square x. And cos x square x we already know. Right, everybody? Cos x square integration 2 cos x square x is this. Again, it's integration we are doing still, right? We are still doing integration. I have not done that. Plus, ये क्या होगा? Cos x by sin square x. Cos by sin is cot. And one extra sin in the denominator. उसको ऊपर ले आओ तो cos x. No, these are familiar form, right? That's it. What will integration of 2 cos x square x? Tell me now. Cos x square integration is minus cot x, right? So minus 2 cot x. You are right. Plus 3. What is integration of cot x, cos x? I told you we already know the standard function. Cos x, cot x is what? Minus cos x? Right. So plus c. So main point is we just split it in the numerator. We split it in two parts. That is more handy. That's it. Too easy. I believe no one will have any doubt here, right? Trigonometry, basic trigonometry. All good. CC, everybody quickly. I want to do a few more questions today. Next. This question everybody will solve and give me the answer only on the chat. My question is integrate sin y by 1 plus sin y, obviously with respect to. Please try. Sin y by 1 plus sin y. And Tusham, something you told earlier may be useful here. Rest and denominator, right, Tusham? That is the first step. Because we don't want denominator. So denominator exercise में Tusham क्या करने वाले हैं? What we want to do? We are going to, okay, this dy, everybody is there, guys. Just assume. So we are going to multiply with 1 minus sin y and 1 minus sin y. Right. So what will happen? Denominator में हो जाएगा 1 minus sin square y. बाद में देखेंगे. Numerator will happen sin y into 1 minus sin y, right? Or let me multiply sin y into 1 minus so sin y minus sin square y. This step is clear. Now what we are going to do? We have done this for purpose, right? Because we want to make it. We don't want, say guys, the rule of thumb is we don't want two terms, single term. So 1 minus sin square y is cos square y, everybody knows. So this become cos square y. अब क्या करने वाले? Yes, Tushar, we got cos square y. So sin y minus sin square y divided by cos square y. अब क्या होगा? Now, tell me anybody. We are going to split the numerator into multiple parts, two parts. Right, Aditya? Suryansh. So, we split, it will become sin y by cos square y minus sin square by cos square y. तो लिख लेते हैं यहाँ पे. sin y by cos square y क्या हो जाएगा? sin y by cos square y. Sin by cos is 10 and cos y डिनोमिनेटर में ऊपर चला गया. ये तो हो गया ये. Minus sin square y by cos square y 10 square y. This is what my question becomes now. Is it solvable? Let's see. 10y sec y तो we know integration, correct? But इसका क्या करेंगे? 10 square y we don't know. We don't know 10 square y. अब क्या करने वाले हैं? Any ideas? It's very easy. We know 10y sec y integration. Right, Suryansh. We will again use the identity 1 plus 10 square x equal to sec square x. So, minus 10 square x equal to 1 minus secant square x. So, ये पूरा बन जाएगा 1 minus secant square x, right? So, I converted into 1 minus secant square x. Now I know of all the three. I know for this, I know for this, I know for this. I know we can integrate. Yes, Suraj is doing very good. So, integration of 10y secant y is what? Secant y? What is integration of 1? Why? One is integration of secant square y. Tell me, anybody has any confusion or how we solve? Right. Answer is this. So what helped us is we saw 1 plus ny in the denominator. Tusham said we will rationalize. We rationalize it. Then Suryan said we will split. And then Suryan said we have done using the identity of 1 plus 10 square equal to secant square. That's it. One question for you now, guys. You will solve it. I will just ask you for the answer. Agree? Let's see. This time you will solve. I will not say anything. This is clear. Shall I erase this? Just say CC, all good. Then I'll move it. I'll remove it. Please solve. Do integration of secant y divided by secant y plus 10y with respect to y only, dy. Okay, so nothing to worry. Solve this and tell me the answer. Everybody, I'll give you 30-40 seconds. Yes, please solve this now. And all the integration, we have to learn technique. We have to do a lot of algebra, a lot of trigonometry. And as we move to level 3, 4, 5, we'll use a lot of methods, substitution method, elate, and there are so many. Integration is huge. But this base will be very useful. Because everywhere you have to put some ways of simplifying it to the form which you want. Okay, then what? So I'm not doing substitution yet. Substitution wise also we can do, but before that. Okay. Okay, so we can do that method where we put something and then differentiate and substitute. But I want to use something else. As of now, without we have not moved to level 3 where we're going to substitute and differentiate. Rationalizing method. Okay, okay, Surya. How you rationalize? What you want to do rationalize? What you want to multiply with?
Multiplying and dividing with secant y minus tan y.
Correct. Let's do that. Secant y minus tan y by... Actually, I should not solve it. You should solve and give the answer, guys. I told, but I forgot. So you should solve and tell me, give me the final answer. Minus tan y. Correct, guys? Let's first talk about denominator because we are rationalizing. Secant y plus tan y by secant y. A plus b into a minus b. It is a square minus b square. Secant square y minus tan square y. कितना होता है? Secant square y minus tan square y. Tell me, guys, trigonometry identity. 1 plus tan square equal to secant square. Or secant square minus tan square is 1. So denominator तो 1 बन गया, right?
Yes, sir. Yes, sir.
Denominator become 1, which is very easy. So denominator तो बहुत easy हो गया. 1. Numerator में क्या हुआ? Secant y into secant y. Secant square y. You will be amazed कि अरे इतना मुश्किल क्वेश्चन इतना easy हो गया. Minus secant y tan y. हो गया ना क्वेश्चन एकदम easy. We know secant y का integration. We know integration of secant y tan y. 1 तो चला गया. So after integration it will be tan y. So right, Aditya, Suryan, see, we didn't use that substitution here. We still will solve it. Yes, in difficult questions we are going to use it, but here it was not required. We just rationalize it. It worked. Everybody okay on this? Ready for the challenge? Tell me who is ready for challenge now. Let's do one question at least. Ready for challenge, RFC. Ready for challenge? Let's start. Question is, it looks difficult, but it is not difficult. Sine to power 6 y plus cos of y to the power 6, just like this. See, it looks difficult, but otherwise, if we apply something, and here I write sine of no, ideas are welcome. Tell me, just think about it. Okay, dy, we are doing it. We are integrating with respect to y. Sine 6y plus sine of 6y means power 6, I am saying, okay? Sine y to the power 6 plus cos y to the power 6 divided by sine square y cos square y. How we are going to do it? Ideas. Any ideas? And I give hint, you require algebra here. Right, Suryansh? You know the identity a cube plus b cube. A cube plus b cube is given by what? A plus b. And when I taught trigonometry to my other classes, I always say, when there is sine square and cos square, always try to add and square. It will be very useful. Minus 3ab a plus b. This is the formula of a cube plus b cube, right? Now, why this is useful? Because in the denominator you see sine square y cos square y. तो sin square y को a सोचो और cos square y को b सोचो. What I'm trying to tell you is, if you think like that, it becomes very easy. Imagine कि sin y तो तुम्हारा है. I'm not substituting. I'm just telling you to think. Cos y, not sin y, sin square y. मजा तो तभी है, sin square y. No, your idea is correct, Suryansh. So, sin square y को a मानो, sin cos square y को b सोचो, तो तुम्हारा तो there you can write a cube plus b cube को कैसे लिख सकते हो? So, if you have to write this, इसको मैं ऐसे भी लिख सकते हैं, sin square और tell me everybody, ये भी तो sin 6 ही हुआ ना, और इसको भी मैंने लिख दिया. So tell me, this is the meaning of this or not? Sin y to power 6 मतलब ये होता है ना, sin square y का क्यूब और cos square y का क्यूब, not 6, sorry. Cos square y का क्यूब मतलब cos to 6y, right? So same thing I can write. So now this becomes, अगर ध्यान से सोचो, a cube plus b cube हो गया ना? इसको हम लिखेंगे इस फॉर्म में. तो स्टार्ट. इट्स a plus b whole cube. a plus b यहां आएगा whole cube. a क्या है? sin square y. Let me write with the hand only. With my sin square y is a plus b is cos y, cos square y. अगर वो सिर्फ cos y होता तो फायदा नहीं था. It is square, sin square y. हाँ तुषाम, that is the magic of this. Because sin square plus cos square will give you 1. तो मैंने लिख दिया a plus b cube minus 3ab, a तो सेम है sin square y cos square y, correct? So 3 sin squared y cos squared y, ये मेरा हो गया a क्यूब प्लस b क्यूब इक्वल टू a प्लस b होल क्यूब माइनस 3ab. अब आएगा यहाँ पे a प्लस b. लेट मी शिफ्ट दिस लिटिल हियर. अब यहाँ पे आएगा मेरा a प्लस b. a फिर से क्या है? sin square है. See, the whole advantage of this thing is the moment we see sin square cos square, we can start using somewhere sin square y plus cos square. It becomes so easy, guys. Now numerator divide by same denominator, same. I am not writing it here, same. Now what happens? Now it become too easy. Let me erase this. This we already know. This sin square plus cos square is 1. 1 cube is 1, so 1. Minus 3 sin square y cos square है तो ऐसे रहेगा. So 3 sin square y cos square y. वो ब्रैकेट में फिर से क्या है? sin square y plus cos square y. This also become 1. ये तो हो गया. डिनोमिनेटर में क्या है? sin square y cos square y. Shall we split? तो यहाँ पे हो जाएगा sin square y cos square y. तो यहाँ पे भी sin square y cos square y. It become little easier. Now what? Tell me anybody, what will do now? Ideas. ये तो चला जाएगा. प्रॉब्लम इसका नहीं है. प्रॉब्लम इज दिस. My question become right, Jayasuriya. That is the master stroke. Guys, this is very interesting in integration. See, generally, what we learn in trigonometry and all that, we should always try to make sin square plus cos square equal to 1. But here we solve few problems. We are changing 1 to sin square plus cos square. And you will see why. I'll explain why. So, let me erase the left side. We'll only write the, let me erase all this. Let me erase all this. So first let me write the question, what question becomes, and then I'll tell you why we are doing this. So my question becomes now 1 over sin square y cos square y. And that is a very good utility you can use in many places in trigonometry and here. -3, correct? ये मेरा question बन गया. So forget this now. Let me erase this so that we have. This is the question now. Now as Jayasuriya pointed out very beautifully, we'll write this one. This one we'll write as sin square y plus cos square y. And you will see why. Sin square y plus cos square y. You know what happens now? Sin square y plus, I wrote 1 as sin square y plus cos square y, and denominator is still sin square. Let me denominator also write in the form of this pen, which is more easy. So this is there, and then we have sin square y, cos square y, and there is a multiplication here. So it is like this. So tell me now, how it will be useful? Jayasuriya, I said done this, but why it is useful? Why am I? 1 second, guys. Let me make it proper so that it looks good. So this is our question. Sin square plus cos square by sin square cos square है -3. -3 का no problem है, उसका इंडिकेशन हो जाएगा -3y. Why we are doing this? Because when you split numerators, it becomes sin square y by sin square cos square y. ये आ जाएगा एक और एक आ जाएगा एक. So it becomes so easy. It become what? Sin square y by sin square cos. तो वो ऊपर हो जाएगा secant square y. Correct everybody? Plus cos square y by sin square cos square y. तो हो जाएगा 1 by sin square मतलब cos x square y. That is the we become a very denominator goes only numerator. और -3 तो already है ही. See, now we know secant square y का integration. We know cos x square y का integration. So that's it. So don't hesitate when there is one. You don't hesitate to substitute sin square plus cos square into 1. It helps if the denominator is that. Yes, Aditya. Yes, Jayasuri. That's it. अब तो इंटीग्रेशन करना है तो बहुत इजी है. secant square y का हो गया 10y, इसका हो गया minus cot y. Interesting. And plus c. Any question on this? Mute. किसका आवाज आ रहा है इतना? Mute.
Sir, one doubt, sir.
Yes, Jayasuriya, please ask me.
Sir, tan y minus cot y minus 3y are the curves in the plane, sir. Am I right, sir?
Yesterday I explained, na?
Yes, sir. I am just asking a doubt. These are the curves, right?
Tan y, cot y, no. The differentiation, no. See, this is the curve, and this is the tangent of it. See, any curves are represented by, say, x square, y square, z square, right? Quadratic, right? Or cubic. So those curves will have same axis, and then these are the tangents which are parallel. So integration represents the tangents, not the curve. Tangent on the curves. That is the point. It was easy, everybody. Interesting. So that is what level 2. In level 3, we are starting with substitution and other methods. And this all will be useful, which you done in level 1 and level 2. Please ask any other question, anyone, before we close today's class. This is understood, everyone? Baramappa, Jayasuriya, Mahesh, Tusha, Musha, Vasu, Virendra got disconnected, looks like. Okay. Suryansh, all good? Okay, then. See you tomorrow, next Saturday. We are going to do higher level integration now with substitution and all other methods slowly, every class. Okay? So that's all. Thank you, everyone. Bye-bye.